Any hello, am I audible? I'm writing
So
some.
your voice
Let
is
me
lagging.
see whether you can hear
Your
me.
voice is lagging.
Okay, okay, just give me a second. I will join you. Okay, how about now? Is it good or is it still lagging? There's a problem in this. Tell me guys, am I still lagging? Hello,
No, sir.
fine now?
Yes, much better.
Much better. Hopefully ऐसे ही रहे. So in the last lecture, we talked about what did we talk about in the last lecture? About the Planck's quantum theory. And today we are going to talk about another important kind of an experiment that is known as photoelectric effect. Photoelectric effect. So what is photoelectric effect? Please write this with me. I will explain it once we have written this effect. Okay. What is photoelectric effect? Please write with me. Ejection of electron. Please write the ejection of electron from metal surface when light of suitable frequency light of suitable frequency strikes the surface of metal. Okay, so this particular phenomena, this whole thing, ejection of electron from metal surface when the light of suitable frequency, it strikes on the metal surface, that is known as photoelectric effect. Okay, metal is called photoelectric effect. Okay, photoelectric effect. You can understand it very easily by two photos, rather, I would say. Okay, I hope you have written this down. Photoelectric effect, the ejection of electron from the metal surface. Okay. Wait, just give me a second. Yeah, I hope you can see from here. So this is the metal surface, as they have written metal plate. And in the metal, there will be atoms. In the atoms, there will be electrons. And those electrons will be binded with the proton. There will be proton which is attracting those particular electrons. Okay. Obviously, there will be a limit to the attraction. So when an electromagnetic radiation which has certain energy, it hits the metal surface, and it hits the metal surface. And if the electromagnetic radiation it is having a frequency which is greater than the attraction between electron and the proton, then and then what will happen? The electron will get ejected. Okay. So basic है, electron, it is folded by proton. There is some attractive forces. If I radiate an electromagnetic wave on the metal surface, it is having a frequency which corresponds to energy greater than the attraction energy. Then what will happen? The electron will be ejected out. Now, how this particular thing was done? See here. So basically, this is you can see that the circuit, and what happened? Here we have metal. Okay, here we have metal, and then light of large energy or high frequency was shined upon the metal. And what they saw was there was some kind of shining in the zinc sulfide coating here. So obviously, how this shining happened? Because of certain electrons, because there is no electricity, as you can see, है ना? यहाँ पे आपके पास क्या दिया? This is battery. Battery is what? Variable battery है ना? Variable voltage इसमें हो सकता है, ठीक है? So the light or the green light because of zinc sulfide was only given when there is some light striking on the metal surface. Okay? So by this, this is the experiment. We don't need to remember this one too much, but this is important. That electromagnetic radiation, it strikes on the metal surface and electron is ejected. There are a few points that you should write. Don't worry about you can make a schematic diagram, not exactly. ठीक है ना? इलेक्ट्रॉन एक दो इलेक्ट्रॉन को आप eject करते हुए दिखा दीजिए. There are few points that you can write. ठीक है, please write with me. Certain frequencies right, were able to eject electron from the metal surface from the metal surface. Not all the frequencies, only certain frequencies of the light wave were able to eject the electron. Next point, please write it. The minimum amount of energy required by electron to show photoelectric effect. So by the way, metal या electron दोनों लिख सकते हैं ना, क्योंकि हर metal का अलग अलग energy requirement होगा. Like for example, we will see also a list, and then we can extract some idea about the uh, atomic structure from the photoelectric effect. Okay, so now we are only writing some points to understand that conclusion that we are going to draw from the data. Okay, so basically the minimum amount of energy required by the metal the electron to show photoelectric effect is called threshold energy, or work function. So these are just the terminologies, work function. Threshold energy or work function is known as threshold energy. It is represented by W. It is E, or you can also write it as E naught. Okay, E naught represents the minimum amount of energy required by the metal atom to show photoelectric effect. Okay, guys, am I not audible?
No, sir, we can hear you.
You can hear me now? Okay, fine. Harshit, I think there is some problem from your side. Okay. E naught, it is equal to H into mu naught. H into mu naught. And this mu naught you can call as threshold frequency. Threshold frequency. Acha. We also know that what is frequency? It is C upon lambda. So we can write H. C will be the constant. Lambda will change with frequency. So lambda naught. What will be lambda naught? Will be known as threshold wavelength. Threshold wavelength. I'm trying something just to know if it works or not. Am I still audible? Tell me, guys. I will read a few lines. The minimum amount of energy required by metal or electron to show photoelectric effect called threshold is your work function. Am I audible still now?
Yes, sir.
Yes, sir.
Fine. Good. ठीक है? I hope you are writing. You can pull a bit down. अच्छा, अब यहाँ पे हम ऐसा बोल सकते हैं ना? If the
Sir,
threshold
can you
energy, that's right. I can scroll up. By the way, those who have done writing, you know, and those who are writing also, they can hear you. Very easy point. If the threshold energy is low, that means we have energy to remove the electron. We can say that it is easier to remove electron. If certain metal is showing less or it is having less threshold energy, it would mean that removal of electron from that particular metal is easy. Make sense? Yes or no? Please tell me.
Sir,
Sir,
can you
can you
repeat?
जल्दी बताएं हाँ या ना? Sorry.
Sir, can you repeat?
Okay. I'm saying if a metal has lower threshold energy, it will be easier to remove electron from there because it requires less energy to remove for showing photoelectric effect. And what is basically photoelectric effect? Is the removal of electron from the metal surface. So if threshold energy is low or the work function is lower, that means it is easier to eject electron. Make sense? Yes or no?
Yes,
Let
sir.
me write this point down and then maybe we can say that lower the work function, easier is the ejection of electron. Easier is the ejection of electron. Next point. Next. If energy of electromagnetic radiations are sometimes also called light. If they say light also, then you will understand it is also talking about electromagnetic radiations. So I will be using these words interchangeably so that you are aware of all of these words. Okay, so right now I'm going to write what is the energy of light. And what is light here? Light is electromagnetic radiation. The energy of light, if the energy of light is greater than the work function, that is W. ठीक है, I hope you will understand work function. या फिर हम E naught भी लिख देते हैं so that you can understand threshold energy. ठीक है. Then the extra energy will be converted to the kinetic energy of electron. It's very easy now. Like for example, an electron requires 5 joules to get removed from the metal surface. Ejection requires 5 joules. If I am giving a radiation of 10 joule, the extra 5 joules, what will happen? It will be converted to the kinetic. So electron will be removed with some kinetic energy, with some velocity. Make sense, everyone? Yes or no? Please tell me.
Yes, sir.
Sir,
Okay,
can you
very easy.
explain the second point again?
Can you have you written it down, Zainab?
Yes, sir.
Yes, you wrote it down.
Yes, sir. Yes, sir.
Okay. Let's suppose we have electron which requires only 5 joule of energy to get removed from the metal surface. So what will happen if I give 5 joule of energy? It will get removed. Make sense? Correct, है ना?
Yes, sir. Yes.
But if I give 10 joules, then the electromagnetic radiation, it will remove the electron with a particular force. And that force will first of all remove the electron, and the extra force jo hai, that will convert, what will do? That will convert into kinetic energy of the electron. The electron will now get ejected with some kinetic energy. Make sense? Yes or no? Please tell me.
Yes, sir.
So we can do something here, for example. ऐसे लिखते तो आप लोग देख लीजिएगा पहले, उसके बाद है ना कीजिएगा. So let us suppose there is an electron which has been ejected with certain velocity or certain kinetic energy. So there will be 5 joules. This is the work function plus the kinetic energy that the electron is having. When I sum this up, it will tell me about the energy of the radiation. That this is the energy that we have given to the metal surface. This much energy is used for the ejection, and the kinetic energy is the remaining energy. Okay. Next, we can write the kinetic energy will be equal to kinetic energy will be equal to E minus W. E will be what? Energy of the light, and energy of light can be written as h nu. And work function, it is what? We have seen that it is E naught, which is equal to h into nu naught. And we can say that kinetic energy of a substance, or rather, kinetic energy of the electron will be equal to h into nu minus nu naught. Okay, please copy this down. Is everyone done writing yes or no? Please tell me.
Yes, sir.
Yes.
Yes, sir.
Please write a question. Light bulb having wavelength 62 nanometers strikes the metal surface. The work function of the metal surface is 13 electron volt. Calculate the kinetic energy of the electron ejected. Okay. कैसे करना है इसमें? First of all, we look at the data, and then we are going to give the data some name. So 62 nanometer will be what? Lambda. Lambda it is equal to 62 nanometer. Right. Then it's time the work function. Work function is 30 electron volt. W is given as 13 electron volt. Right. They're asking for kinetic energy. We have just seen that kinetic energy will be equal to E minus W. Right? E minus W. Achha, if you remember that if I have lambda in lambda in nanometers, and we want to talk about energy in the terms of electron volts, then we can use a very simple formula, that is 1240 divided by lambda. So this E represents what? This E represents the energy of photon that is hitting the metal surface, So this can be written as, E could be written as 1240 upon lambda. This will be giving you energy in electron volts, minus the work function is also in electron volts, so you can write 30. है ना? So this is also electron volt, this is also electron volt. Will be giving me some data in electron volts. Now this will be equal to 1240 divided by lambda. What is lambda? 62. We are not going to write nanometer because this formula already has that nanometer in itself, right? Minus 30. So 62, I think, will go by 2, right? 20. So we will get 20 minus 13 will be 7 electron volts, which will be the kinetic energy. If the value is if it is in joules, or if they're asking in joules, so you can multiply 7 into 1.6 into 10 to the power minus 90. This will be now joules. 7 into 1.6 will be approximately equal to how much? Will be approximately equal to 10.5. 8.5 or 10.5 or 10.6 is very good. 10.6 I'm writing approximately. 10.6 into 10 to the power minus 19 joule. थोड़ा और ज्यादा हो सकता है क्या? What is 16 into 7? 42. That it is a bit larger. 10, 112, 1.11.2 होगा. ठीक है, so this will be equal to 1.12 into 10 to the power minus 20.
So can you scroll up?
Record the question.
Yes.
Now, after this, we are going to write the conclusion. That is also self-explanatory. Then we are going to look at data. Okay, na? And that data is going to give us some idea about the position of electrons and everything. And that is going to give you like how Bohr he came up with the different orbits and everything. Let me know once you're done writing. Please raise your hand. Okay, Sabiha is done. I'm waiting for others. Waiting for Jobita, Jasleen, and Sabiha. Jobita, Jasleen, and Sabiha. It's done, nothing. Only waiting for Jobita now. Jobita is also done. चलिए मूव on. तो जो कंक्लूजन लिखना वो पहले लिख देते हैं, उसके बाद वी आर गोइंग टू लुक एट द डेटा. ठीक है, द डेटा इज गोइंग टू टेल अस सो मेनी थिंग्स. So please write conclusion. This conclusion is regarding what? This conclusion is 20. photoelectric. So whenever electromagnetic radiation it strikes metal, or when light strikes metal, so we can write when electromagnetic wave strikes metal. So there are three possibilities. There are three possibilities. Three possibilities में क्या क्या है? First is if the energy, it is energy of what? Energy of the electromagnetic radiation. It is less than the work function. Then nothing will happen. It will strike the metal surface. Electron, it does not have that much energy to remove the electron, so nothing will happen. Nothing happens. Also, we can say no photoelectric effect, no PE. Justine, you want to say something? Your hand is raised till now.
No, sir.
Okay. Now, when the energy is equal to the work function, then what will happen? Electron is ejected with zero kinetic energy. There is no kinetic energy. उसके बाद क्या है? Electron, sorry, not electron. Electromagnetic radiation, it has energy greater than work function. And in that case, electron is ejected with some kinetic. Okay, so these are the three things that could happen. उसके बाद we need the data. So data दिखाते हैं उसके बाद we don't have to write the data है ना, कुछ नहीं करना आपको data का. उसमें से we are going to choose three metals and then we are going to talk about those three metals. Done, everyone? I hope you guys are done. Yes, so anyone still writing, please let me know.
Yes, sir.
Anyone still writing? Writing. Anyone still writing? Anyone still writing? Anyone still writing?
No,
One.
sir.
No, sir.
ध्यान दीजिए. Oh my God, timer is coming now. See, we have work function of too many elements यहाँ पे है ना. देखिए ध्यान से देखिएगा जरा. We don't need this many elements. बस इसमें से सारा डेटा हमने बस ऐसे रख दिया आपके सामने. So important is we are going to focus on these three: beryllium, calcium, and magnesium, because they are in the same group. ठीक है? So can you tell me which is having the highest between beryllium, calcium, and magnesium? Which is having the highest work function? सबसे ज्यादा किसका है?
Beryllium.
Beryllium is having the highest. After that,
Magnesium.
magnesium, and after that,
Calcium.
calcium. Can you see that there is certain pattern In the periodic table also, we have beryllium, then magnesium, then calcium. And what this suggests? It suggests that beryllium से electron निकालना, it is easier. Sorry, it is very tough. My bad. It is very tough comparative to magnesium and comparative to calcium. So we can say that in beryllium, the electron is near to the proton or the nucleus. Magnesium is a bit far away. A bit far away. In magnesium, the electron is a bit far away. That's why it is easier to remove the electron. In calcium, it is easiest because it is quite far away. Makes sense? Yes or no? Please tell me.
Yes, sir.
So that's the reason why Bohr came up with this idea that if the electron is near to the nucleus, or it can be a certain far away, or it can be quite far away, and so on. So you can see that how he understood about shells, or he gave a theory like why is beryllium having higher work function than calcium and magnesium. The reason is what? The reason is, अच्छा एक और चीज समझिएगा जरा. Okay, this is quite weird because if you look at the proton in beryllium, how many protons beryllium has? Hydrogen, helium, lithium, beryllium. Only 5 protons. ठीक है ना? 5 positive charge. Magnesium पे कितना positive charge होगा? What is the electron number or the atomic number of magnesium? जल्दी बोलो 12 है ना? Magnesium has 12 protons ना? Atomic number 12 होता है. Calcium का 20. So what should be expected? We should expect that calcium should hold the electrons much tightly because it is having more number of protons. And if it is holding the electron much tightly, it should have higher work function. But it is opposite. Calcium is having the lowest work function. Beryllium, which is having only 5 protons, it is having very high work function. So then Bohr said this could only be possible if the electrons are near in beryllium and it is a bit far away in magnesium and a bit far away in calcium. Does this make sense? Yes or no? Please tell me, guys. How this data tells us about shells? Yes or no?
Yes, sir.
What about others?
Yes, sir.
Any doubts in this? Please tell me.
No, sir.
No, ना ठीक है. शाइमा, प्लीज बी ऑन टाइम ना. कैसे लेट हो रहा है आपको इतना? ठीक है, यू डोंट हैव टू राइट दीज थिंग्स, है ना? ये आपको मतलब ऐसा कुछ मतलब एनसीईआरटी ने ऐसा बोला नहीं कि आपको सारी चीजें पता होनी चाहिए, ठीक है? बट जस्ट टू मूव वेरी स्मूथली टुवर्ड्स द बोर्ड्स मॉडल, नाउ वी कैन स्टडी बोर्ड्स मॉडल एंड वी आर गोइंग टू स्टडी बोर्ड्स मॉडल. नाउ वी कैन से दैट ओके फाइन, शेल्स होते हैं, तो व्हाट डिड एक्चुअली बोर्ड से? ठीक है, तो उसको बारे में हम लोग लिखते हैं. वी डोंट हैव टू राइट एनीथिंग ऑन व्हाट आई एक्सप्लेन, विल डायरेक्टली राइट बोर्ड्स मॉडल. Bohr's model of atoms. By the way, the explanation that I did, it is a very dumbed down explanation of the Bohr's model and how he concluded on the various stationary orbits of his model around in the atom. Bohr also did a lot of work on the hydrogen spectrum. ठीक है ना? So hydrogen spectrum पे काफी काम किया था उन्होंने उसके बाद. But I don't have very easy explanations for the 10th standard students, है ना? Because I have to treat you guys like 10th standard students. I will be 11th में आए हैं. So the knowledge you are having in 10th standard, I really don't know how to like dumb it down till the 10th standard. So this was very easy to explain and easy to understand for the kids. That is why this is one of the aspects of the path towards Bohr's model. There were other observations also from which Bohr extracted many things. ठीक है ना? So after a few more years of experience, if I am able to explain, then फिर आगे किसी बच्चे को explain करेंगे. But right now, Bohr's model के लिए हम ऐसे ही smoothly भाग सकते हैं from the work function. What we can say about Bohr's model? First of all, he said that the first point he said, electron is revolving in circular path around the nucleus, circular path around the nucleus called orbit or shell or energy level. ठीक है, you write the second point. If the electron is present in a particular orbit, then it can neither radiate, radiate का मतलब लूज होता है, neither radiate energy nor absorb, nor absorb energy. Absorb का मतलब it cannot gain energy also ना. Therefore, energy of each orbit is fixed. Energy of each orbit is fixed. ठीक है, it is fixed. अब you please write it down. ठीक है, the second and third points you may find it contradictory, but I will explain it. Don't worry about it. Just give me a second here. I will just update the just give me a second, please. Structure of atom, Bohr's model आज हम लोग फिर करेंगे. And the third point is energy of electron changes. Energy of electron changes with change in its orbit. ठीक है, अभी तो बोल रहे थे एनर्जी चेंज नहीं होगी, अभी बोल रहे एनर्जी चेंज होगी. बोल साहब क्या कर रहे हैं आप? बोल साहब ने सही लिखा है, वो हम लोग बताएंगे, है ना, वो हमारे समझने की थोड़ी सी कमजोरी है. ठीक है, बट आई विल एक्सप्लेन. You write next point. The transition of electron, the transition of electron from one orbit to another, from one orbit to another, is accompanied with change in energy. Okay. Do you find the second and the second point and the next points a bit contradictory? Yes or no? Please tell me. If you find it contradictory, then I will explain. If you have understood the language of Bohr Sahab, then I don't need to.
Can you explain,
Is it
sir?
contradictory? Yeah, okay, fine. So we are fine. Let's suppose an electron is in third orbit. Where is the electron, Sabiha?
Third orbit, sir.
Third orbit. So until and unless till it is in the third orbit, it will have certain energy. It will have certain energy when it is in the same orbit. As soon as it loses energy, it will not be in the third orbit. It will be in the second orbit. As soon as it absorbs energy, it will not be in the third orbit. It will be in fourth orbit, fifth orbit. So if an electron is in one orbit and it wants to be in that orbit, it cannot lose energy or it cannot absorb energy. As soon as it absorbs or loses energy, its orbit will change. That's what Bohr Sahib is trying to say. Now it makes sense, yes or no? Please tell me.
Yes, sir.
ठीक है. वही लिखा है स्टार्टिंग में, इफ द इलेक्ट्रॉन इज प्रेजेंट इन अ पर्टिकुलर ऑर्बिट, if you are not changing the orbit, then you cannot lose energy, you cannot gain energy. As soon as you lose or gain energy, there will be a change in the orbit also. ठीक है, चलिए अब उसके बाद देर इज मैथ्स विद बोर्स, है ना। कोई डेरिवेशन आप लोग इसमें से पढ़नी नहीं है, ठीक है। डोंट हैव टू लर्न अबाउट एनी डेरिवेशंस एंड एनी, कुछ नहीं पढ़ना आप लोग को, ठीक है। देयर आर फ्यू फॉर्मूलाज दैट यू नीड टू रिमेंबर, एंड उससे बहुत लाइक दोस क्वेश्चंस आर जस्ट एक फॉर्मूला लगाइए, आपको आंसर मिल जाएगा, ठीक है। एंड आई विल आल्सो गिव यू अ ट्रिक टू रिमेंबर दोस फॉर्मूलाज. I hope everyone is done writing till here. Yes or no? Please tell me. Is everyone done? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Yes, sir.
चलिए नेक्स्ट लिख दिया आप लोग। बेसिकली हम तो यहाँ लिखाते हैं मैथमेटिकल एनालिसिस ऑफ बोर्ड्स मॉडल, बट दिस इज जस्ट मैथ्स, नथिंग एल्स, दिस फॉर्मूलास, ओके। मैथमेटिकल एनालिसिस ऑफ बोर्ड्स मॉडल, ठीक है। और इसमें सबसे पहले उन्होंने रेडियस ऑफ ऑर्बिट के बारे में बोला है, नंबर वन, रेडियस ऑफ एन ऑर्बिट, ठीक है। सर कोई एक्सपेरिमेंटेशन या फिर कोई एक्सपेरिमेंटल प्रूफ आपके सिलेबस में नहीं है, तो हम आपको थोड़ा सा बस बता देते हैं कुछ कुछ चीजें। यहाँ पे देखिए, रेडियस ऑफ लेट सपोज फर्स्ट ऑर्बिट, सेकंड ऑर्बिट, थर्ड ऑर्बिट, it is equal to n square, n is the orbit number, first orbit second orbit जो भी है, into h square, that is a Planck's constant, divided by 4 pi square m into e square, ठीक है, m into e square into z, ठीक है। या फिर इतना जो था ना, दिस मच फॉर्मूला, इट वाज फॉर हाइड्रोजन, बट z लिख लीजिए, दिस विल बी एप्लीकेबल फॉर ईच एंड एवरी एलिमेंट, ठीक है। सर व्हाट इज दिस सर, सो मच such a large formula? Yes, it is large, but there are few constant. Planck's constant है, 4 भी एक constant है, pi भी एक constant, is also constant, electron is also constant. तो इन सबका एक constant रहेगा वैल्यू, तो radius will be equal to 0.529, बचा क्या, n square upon z, fine, and this will come in the terms of angstrom. This will be in term of angstrom. What is n here? N is equal to the shell number. And what is z here? Z, it is equal to atomic number. चलिए प्लीज कॉपी दिस डाउन। सवाल करेंगे हम लोग, छोटे सा सवाल करेंगे, डोंट वरी अबाउट इट। दो सवाल करेंगे, दैट विल गिव यू एन आइडिया ऑफ टू डिफरेंट टाइप्स ऑफ क्वेश्चन दैट कैन बी आस्क्ड, ठीक है। बेसिकली यहाँ पे ना दिस फॉर्मूला दैट वी आर गोइंग टू लर्न अबाउट रेडियस, देन वी आर गोइंग टू लर्न अबाउट एनर्जी ऑफ एन इलेक्ट्रॉन इन अ पर्टिकुलर ऑर्बिट और द एनर्जी ऑफ एन ऑर्बिट। ये दो जो फॉर्मूला है आपके पास, उसके बाद आपको वेलोसिटी का भी फॉर्मूला पढ़ा देंगे, ज्यादा हार्ड नहीं होगी। हाँ वो पढ़ाएंगे जैनब, अभी तो रेडियस खत्म नहीं हुआ, अभी हम बता रहे हैं। चल में ठीक है, हम बताएंगे, यू विल अंडरस्टैंड इट। डू यू अंडरस्टैंड दैट फॉर्मूला जैनब, बाय द वे, जो आपने लिखा है?
Yes, sir.
यू अंडरस्टैंड इट? कैन यू टेल मी अबाउट इट? आर इज इक्वल टू क्या
Sir.
लिखा आपने, ए नॉट एन स्क्वायर अपॉन जेड ना?
Yes, sir.
व्हाट इज ए नॉट?
It is the angstrom value, 50
हाँ
angstrom value. Angstrom
एंगस्ट्रॉम
value.
वैल्यू, एंगस्ट्रॉम वैल्यू
So that's
वो
what they
बताते हैं क्या,
taught in
ठीक है
the
ना?
school.
वो कुछ और नहीं, नहीं उन्होंने शायद कुछ और पढ़ाया होगा। हाँ वो हम बताते हैं, डोंट वरी अबाउट दैट। वो आया कहाँ से, ए नॉट क्यों लिखते हैं उसको ना, वो भी हम बता देंगे आपको, डोंट वरी अबाउट दैट, ठीक है। सवाल कराएंगे, समझ में आ जाएगा, ठीक है। चलिए आई होप
Yes.
ऑल ऑफ यू आर डन राइटिंग दिस। सवाल लिखिए, कैलकुलेट द, सवाल है कैलकुलेट द रेडियस ऑफ फर्स्ट ऑर्बिट ऑफ हाइड्रोजन एटम। ठीक है, हाइड्रोजन एटम, ठीक है। सॉल्व करने के लिए तो क्या चाहिए, देखिए आर निकाल रहे हैं किसका, R1 निकाल रहे हैं, रेडियस ऑफ फर्स्ट ऑर्बिट, इट विल बी इक्वल टू व्हाट, 0.529 लिखा है हमने, इनटू n स्क्वायर। n क्या है, व्हाट इज द वैल्यू ऑफ n, बिकॉज वी आर इन द फर्स्ट ऑर्बिट एंड इट विल बी इक्वल टू 1। अच्छा, व्हाट विल बी द वैल्यू ऑफ z फॉर हाइड्रोजन, एटॉमिक नंबर ऑफ हाइड्रोजन, इट इज इक्वल टू हाउ मच, 1, तो 1 स्क्वायर अपॉन 1, so we can from, so 1 will be equal to 0.529 angstrom. Now please try to understand one point, ठीक है ना, ध्यान सुनिएगा, this constant 0.529 angstrom, this constant is basically what, it is basically the radius of the first orbit of the hydrogen atom। ये जो constant है value ना, this n square and z will be constantly changing, because if you are going to go to the second orbit it will be larger, if you are going to lithium, helium, the z will also change. What is constant for in the formula of radius, 0.529 is constant, 0.529 angstrom, it is constant. Now what is 0.529 angstrom, it is the radius of the hydrogen atom. Now important fact is, if note, if R1 of hydrogen atom, R1 of hydrogen atom is equal to A naught, या A कुछ भी बोल दीजिए आप, A, ठीक है, is given, then we can say radius of the nth orbit of any atom, it is equal to A naught into n square upon z। अब ये जो A naught है ना, this radius of hydrogen atom, it could be given to, देखिए आपको जो फॉर्मूला याद करना है in general is 0.529 n square upon z angstrom, or if you want to write in pico, जैसे आपने याद किया कोई दिक्कत की बात नहीं उसमें, but you have to remember this formula। Sometimes what will happen, they will give you the radius of hydrogen atom and then you have to calculate the radius of lithium, helium, कुछ भी हम लोग देखेंगे अभी एक सवाल में, ठीक है ना। So when they are giving you the radius of the first orbit of hydrogen atom, they are actually giving you the constant, ठीक है। तो ये फॉर्मूला बन जाएगा A naught n square z। जैसे सवाल है आपके पास, सवाल, if the radius of first, if radius of first orbit
Sir, your screen is lagging.
of hydrogen atom, my screen is lagging, is it lagging for everyone, is it lagging for everyone,
Yes, sir.
yes, is it still lagging, is it still lagging, देखिए जरा, देखिए देखिए
ज्यादा नहीं सर, थोड़ा सा।
थोड़ा सा बेयर कर लीजिए, ठीक है। इस XPM उन्होंने कुछ नंबर नहीं दिया आपको, then the value of, fourth orbit will be, ठीक है, बहुत आसान है, सही। ए नॉट यहाँ पे क्या दे दिया हम लोगों ने, XPM, एक्स पिकोमीटर, है ना, दे विल ऑलवेज गिव यू सम यूनिट आल्सो। सो R4 निकालना है आपको, किसका निकालना है आपको, हाइड्रोजन का निकालना है, ठीक है ना। R4 ऑफ हाइड्रोजन विल बी इक्वल टू A नॉट क्या है, x इंटू n स्क्वायर अपॉन z, x, तो आपके पास दिस विल बी इन पिकोमीटर्स, XPM, Just give me a second, Shaima. X into what is n? N is equal to 4. 4 का square 16. Z is equal to 1. Because we are in hydrogen right now, it will be equal to 16x picometer. Okay, so this is how they can give you the question. Really. These are the two questions. Please write this down. Anyone still writing?
Yes, sir. Done, sir.
Anyone writing, sir? Please let me know. No one is back. देखिए अभी आप अगला लिखिएगा। ठीक है, लेटेस्ट नंबर क्वेश्चन है ना, वो आप ठीक है। तो the starting is same. A is starting if the radius of लिख लीजिए आप लोग जब तक, if the radius of first orbit of hydrogen atom is x picometer, then the value of, उसके बाद चेंज करना है थोड़ा सा, स्टार्टिंग सेम है। the value of let us suppose आपके पास है थर्ड ऑर्बिट ऑफ लिथियम एटम कर लेते हैं। वैल्यू ऑफ थर्ड ऑर्बिट ऑफ लिथियम एटम। ठीक है, तो आपके पास अभी भी इन सॉल्यूशन में कैसे करना होगा? A naught it is equal to x R3 of lithium atom। ठीक है, बेसिकली वैसे बोर मॉडल इज एप्लीकेबल फॉर सिंगल इलेक्ट्रॉन सिस्टम। तो यहाँ पे आपको ना लिथियम टू पॉजिटिव वो दे सकते हैं। ठीक है ना, लिथियम टू पॉजिटिव एटम या फिर लिथियम टू पॉजिटिव आयन इस तरह से बोल सकते हैं। ठीक है, चलिए बाय द वे होगा क्या, दिस विल बी लिथियम एन की वैल्यू, तो एन की वैल्यू है 3। Z की वैल्यू फॉर लिथियम विल बी आल्सो इक्वल टू हाउ मच? व्हाट विल द वैल्यू ऑफ Z? हाइड्रोजन हीलियम लिथियम भी हो जाएगा ना। चलिए फॉर्मूला में प्लग इन करके निकालिए, आंसर क्या होगा? x पिकोमीटर है। जी जी, आंसर आंसर कॉपी में, कॉपी बोल रहे हैं, चैट में आंसर बताइएगा। Tell the answer in chat. Yes, Shaima correct. Very good. यस मुनीबा करेक्ट, जैनब करेक्ट, वेरी गुड, बहुत आसान है ना। ठीक है, अब एक्स पी एम की जगह वो आपको वैल्यू दे सकते हैं, अदरवाइज यू विल हैव टू रिमेंबर दैट इट इज 0.529 एंगस्ट्रॉम, या फिर अगर पिकोमीटर में तो 52.9 5.29 इन पिकोमीटर इट विल बी व्हाट, पिकोमीटर में 10, हाँ नहीं नहीं 52.9 हो जाएगा पिकोमीटर से। ठीक है, दिस विल बी इक्वल टू व्हाट, ए नॉट इंटू एन स्क्वायर अपॉन जेड। ठीक है, दिस विल बी इक्वल टू एक्स into n is equal to 3, 3 का square is 9, divided by z is equal to 3 in picometers, and this will be equal to 3x because 3 3s are 9, 3x picometers. ठीक है, that's it. चलिए सेकंड चीज जो हम लोग को पढ़नी है, राइट 1 2 फर्स्ट दिखा था हमने, हाँ दिखा था, ठीक है। सेकंड चीज जो हम लोग को पढ़नी है दैट इज एनर्जी ऑफ इलेक्ट्रॉन्स। एन स्क्वायर ए नॉट जो आप लोग बोल रहे थे ना स्टार्टिंग में, एन स्क्वायर ए नॉट इज व्हेन यू हैव फॉर हाइड्रोजन एटम ओनली। हमने जो आपको लिखा है दैट विल बी एप्लीकेबल फॉर एनी एटम और एनी हाइड्रोजन लाइक आयन। ठीक है, तो उसी तरह से एनर्जी ऑफ इलेक्ट्रॉन के लिए भी क्या होगा, इफ यू वांट टू टॉक अबाउट द एनर्जी ऑफ nth ऑर्बिट ऑफ अ पर्टिकुलर एटम will be equal to minus 13.6 into z square upon n square. The unit for this case will be electron volts per atom. ठीक है, there is one more form which you can see, which is En, it is equal to minus 1312. This is again constant, but it is the same like z square upon n square, but this will be in kilojoules per mole. ठीक है, so you can see these two formats. The negative sign, it is just telling us that the energy is attractive force, because आप लोगों ने शायद ये पढ़ा नहीं है, but Coulomb's law एक होता है, F it is equal to K Q1 Q2 upon R square. Q1 is the charge. This is very similar to the gravitational force of attraction, है ना, वैसे ही होता है Coulombic force of attraction between positive and negative charges. Or this force is basically regarding two charges. If Q1 is also positive, and let us suppose Q2 is also positive, then the force will be what, positive, and when the force is positive, the energy will also be positive. Now positive positive में क्या होगा, repulsion होगा. When you have opposite charges, then the force will be negative, and that's why the energy is also going to be negative. So when you have negative energy, it tells you about what? It tells you about the attraction between nucleus and the electron. ठीक है, यहाँ पे next point लिखिएगा. The negative energy,
आपका स्क्रीन बहुत
the
लैग कर रहा है।
negative sign. Is it lagging for everyone? और किसी के लिए लैग कर रहा है क्या? Yes or no तो बोल सकते हैं.
यस सर।
Little bit, अच्छा वेरी अलग अलग डिग्रीज में है. Let me reshare them. क्या कर सकते हैं इसमें हम, समझ में नहीं आ रहा मुझे क्या हो रहा है. ठीक है. The negative sign tells us about, or rather tells about. Is it better now? See, is it better? No, is it not better? अरे हाँ ना, कुछ तो बोलो. Is it still lagging? तभी हाँ.
No, sir, it's working.
It's working now. बोलते ही नहीं आप लोग तो. ठीक है, अब ध्यान से सुनिए. If the electron is having, ध्यान सुनो. ठीक है, I need answers यहाँ पे ना. We have proton. ठीक है, उसके बाद इलेक्ट्रॉन ऐसे ऐसे. Let us suppose this electron it is having, there is some force of attraction. Because of that force of attraction, there will be some energy, and that energy is -5 joules. Okay, this electron is experiencing a attractive energy or attractive force from the proton from the nucleus, which corresponds to -5 joules. इसको बाहर निकालने के लिए, if I want to remove this electron, I will have to give certain energy, and that energy will be equal to 5 joule. Yes or no? Please tell me, guys. क्या ख्याल है? बोलो. No.
Yes, sir.
है ना?
Yes, sir.
ठीक है. So next point, the amount of energy required, the amount of अच्छा भाई जो भी आपका एनर्जी ऑफ इलेक्ट्रॉन उसको पॉजिटिव कर दीजिए, तो वो आपका आयोनाइजेशन एनर्जी बोलते हैं बेसिकली इसको. हम दिखा देंगे क्या होता है एग्जैक्टली. द अमाउंट ऑफ एनर्जी रिक्वायर्ड टू रिमूव electron from its ground state, electron from its ground state to, अच्छा इलेक्ट्रॉन को निकालेंगे कहां तक? तो बेसिकली कौन सा शेल तक लेके जाना है? सो व्हेन वी आर गोइंग टू रिमूव इट फ्रॉम द एटम इटसेल्फ, तो आप समझ सकते हैं, if the electron is not under the influence of nucleus, we have to remove electrons so much far away. We have to remove the electron from the atom. When I remove the electron from the atom, electron is no longer in the influence of the nucleus. So with respect to nucleus, it is at infinity. You can say that, yes or no? Please tell me. क्या ख्याल है? बोल सकते हैं ऐसा? We have to remove the electron. You have to remove the electron from the atom. Once the electron is away from the atom, it is removed from the atom. It is no longer experiencing the attractive force of nucleus. That is why we can say that it is infinitely far away from the nucleus. Make sense, yes or no? बताइए. Make sense? सभी आपको make sense करता है. बाकी लोग तो बोल ही नहीं रहे. Ground state to infinity is called ionization energy. Called ionization energy. तो बेसिकली मान लीजिए आपके पास अभी इलेक्ट्रॉन जो है उसके पास कुछ एनर्जी है, सर्टेन एनर्जी इट इज हैविंग. ठीक है, E1 लेंगे तो आप लोगों को लगेगा कि यदि फर्स्ट ऑर्बिट E मान लीजिए, एंड वी हैव टू टेक इट टू व्हाट, इन्फिनिटी शेल, है ना, बहुत दूर लेके जाना है. So this is initial and this is final. So the change energy required इसके लिए क्या लिख सकते हैं? डेल्टा E, which will be equal to final minus initial, minus initial. ध्यान से देखिएगा जरा. Now for final I will write E infinity. Initial I will write E infinity, यानी the n will be equal to what? N will be equal to infinity, है ना. वैसे मतलब infinity को यहाँ पे रखा नहीं जा सकता in the denominator, मैथमेटिकली सही नहीं है, but to understand we can say that if we have removed the electron from the atom, there will be no energy, or there will be no force of attraction between electron and the proton, and that's why there will be no energy. So energy at infinity will be equal to 0 minus what is the energy of an electron at its orbit is equal to minus 13.6 into z square upon n square, and because we are talking about an atom, so we can say electron volts like this. A negative and negative will cancel each other out. We'll get the energy that is required in positive, that is 13.6 into z square upon n square. ठीक है, this will be in electron volts, है ना. देखिए अब जरा, if I talk about hydrogen atom, I will give you time to write, don't worry. For hydrogen atom, I can say that ionization energy, it is equal to, प्लस में रहेगा ना, 13.6 into z for hydrogen atom, atomic number is 1, and because the electron is in the first orbit of hydrogen atom, the n also will be equal to 1. The square will be still 1. This will be in what? Electron volts. So basically the ionization energy will be equal to plus, rather I should write like this, ionization energy plus 13.6 electron volts. When they are going to give you the ionization energy of hydrogen atom, that means they are giving you the constant फॉर द फॉर्मूला ऑफ एनर्जी, है ना, इस बात को यहाँ पे नोट डाउन कर लीजिएगा. इफ ionization energy of hydrogen atom is given, then 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 you know about, कैसे लिखे हम इसको, एक सेकंड ब्रेक सुनने दीजिए आपको. The ionization energy is given, then the constant in the formula of energy of orbit is also given. ठीक है, चलिए कॉपी कीजिए जरा इसको. If you want me to scroll up, I can scroll up. देखिए एनसीईआरटी में भी ना इस तरह के सवाल आप लोग को मिल जाएंगे कि आपको एनालिसिस एनर्जी दिया हुआ है और उसके बाद वो कुछ और ही पूछ रहा है, ठीक है, एनर्जी वगैरह पूछने लगते हैं. इसमें बच्चे थोड़ा कंफ्यूज हो जाते हैं. सो दीज पॉइंट्स आर वेरी इंपॉर्टेंट, लाइक दिस इज एक्चुअली द ट्रांसलेशंस, यू कैन से. ये सारी चीजें क्या है, ट्रांसलेशन है. दैट इफ दे आर गिविंग आयोनाइजेशन एनर्जी, वो क्या बताना चाह रहे हो, वो आपको कांस्टेंट वैल्यू देना चाहते हैं. Raise your hand once you are done writing.